Hi guys, and welcome to today's video on this year 7 topic. Now I say year 7 if you're actually in a completely different year level. You may be in year 5 and you're like, do you know what? I fancy giving a bit of reflection a go. It's really good to have you. I'm Darren, otherwise known as MaffsGuru. Weird, I know, and I have this little bit of a YouTube channel for you to hopefully learn maths with some humour. Now, if you are new, do me a favour. There is a red arrow over there saying something along the lines of, show me some support. If you click that button, you're actually going to come up and subscribe to my YouTube channel. I am never going to get rich or in fact have any money from this YouTube channel because maths has about 8 people watching it all over the world, but it's good to know that you are. So if you can click that button, I'd be deeply grateful. Now, what am I going to look at this lesson? Well, we're going to look at what it means to reflect something, and you can see a red arrow above me now also pointing out the learning. Hopefully by the end of this video, that's what you'll have done. So know what it means to reflect something. Know what the term mirror line is, how to reflect in common lines. And there I'm saying the x-axis, the y-axis, the line y equals x and the line y equals minus x. Now that might not mean very much to you at the moment, but hopefully by the end it will. How to draw a reflection of something which passes through the mirror line. Now those are the questions that tend to sort of mess with people's minds. And know what it means by the term mirror image, or in fact object and image. Seems a lot, doesn't it? And sadly, you think that actually it was going to be boring, but this is real world maths. Yay, the world goes crazy. There's actually a practical task you can do. All right, I know we're going to throw some maths in as well, but come on, can't have everything in life. So firstly, here's a practical task. Do me a favor, grab your iPad, your phone, whatever you're watching this on, and walk to a mirror. I'll just wait. No, I won't. Once you get to that mirror, I want you to look in it and tell me what you see. Now, tell me, do a comment below, do a like, do something along those lines and tell me what you see. If you see someone else behind you, run for the hills, because this is a really bad and probably cheesy horror movie, all right? If you see yourself in the mirror, that's great. Now, as I sit here at this moment in time, I'm looking into the camera. What you guys can't see is on the right-hand side of me is actually me looking back at me. Now, this is to make sure that I stay in shot. Obviously, it'd be a bit stupid if I put my hand outside, because what you notice now is, yeah, my hand's gone missing. Another creepy horror movie. But what I can see is my mirror image. Well, there we go, tick, I've just done mirror image. I can see myself, but in completely the reverse way. Now, if you've watched any of my videos, what you tend to notice is that when I do left and right, I get them completely the wrong way. That's because my brain does not want to flip this. When you look in a mirror, you will see your mirror image. Now, do me a favor, get closer to that mirror. What do you notice? Well, the fact of it is I've got way too close to that camera and now I've pulled back. But as I push into the camera, then my image gets closer to what you can see. So there's some sort of distance involved in this as well. My mirror actually knows how far behind I am. Alternatively, it's a totally different reality, and there's actually another one of me in that mirror at exactly the same time. If that's not creepy, nothing really is. And I'm so sorry, mate, that you look exactly the same as me. Ew, ugly. But mirror images are really useful, and mirrors and mirror lines are reflecting. But ladies and gentlemen, I'm going to introduce my new assistant. Yes, actually, say hi. Now, I would call him a name, but I've got absolutely no idea what to call him. He's just literally standing there waiting for me to do something. And what am I going to do? Well, I'm going to hand it over to him. Before I do, if you can think of a name for this wonderful character, then do me a favour, leave a comment below. I've got no idea. Cuthbert the Crab. Cuthbert doesn't really fit, does it? But what he's going to do now is he's going to hand over to you and talk about 3 terms. Here we go. Okay, well, thank you. Well, I suppose the first thing is an object, and the object is generally the initial shape. That's it, the initial shape. Now, what about the image? Well, the image is pretty much the shape that's been reflected. It's what you see in the mirror. So obviously you are the original object, and you see yourself as the image. And the mirror line is, well, actually it's like the mirror, in it. Now, in maths, we draw a mirror line with a dotted line, and he already says that. So that's fine, it's all good. So those are the 3 things, and I suppose I better hand you back to him then. Yeah, all right then. Wow, well there we go, a talking crab, who'd have thought? No idea why maths, but obviously I've been playing and I had some fun. But those things there are really important to know. The language of maths is what tends to trick people. Okay, so we've done all the introduction, we've done the language, let's actually have a go at drawing images of objects in the mirror line. Now the first thing is, I'm going to say here something called reflecting in the x-axis. Now I'm going to draw a diagram over here, and these are a set of scales, otherwise known as axes. So here is y and here is x. And if you don't know what a Cartesian plane is, then there is a video coming on that as well. But long story short, we can use these lines, these axes, to reflect in. Now, I'm probably not going to use this at this moment in time. All I'm going to tell you is the x-axis is a horizontal line. And I'm going to draw a dotted line here to stand for my mirror line. Now, what I want you to imagine is that I'm going to put a mirror on that actual line. And I'm going to look and see what my shape looks like when it's reflected in that mirror line. Now, I can't do that in real life. So we have to imagine, and ladies and gentlemen, here is one of the easiest shapes in the world to be able to do. And it is obviously a triangle. Now, when we label triangles, we give it letters A, B, and C. The reason we do this is in a moment when I do my image, and remember the crab was talking about images, then we need to be able to label it in a particular way. But how do we now reflect this? Go back to our view in our own mirror. My reflection is the same distance away from the mirror as I am from it. So that gives you the hint. What I know is that I am looking for the distance between my point A and that mirror line to be exactly the same as my image. So assuming I can draw this accurately, I can now do a dot there, and I know this is A with a dash. Now that dash tells me it's the image. Always important when we draw these things to make sure it's clear between what the original diagram was and what the new diagram was. So, same thing. Here is my point C. How far is it between point C and my mirror line? Okay, so it's that big, roughly. So, now I replicate it on the other side. So, here is C dash. I'm keeping the distance above the mirror line and below the mirror line are exactly the same. And here is point B. I'm now going to look for that distance there, that distance straight to the mirror line. And I'm roughly going to speak, and it's going to be here. Now again, I can't do it accurately. How do you think you're going to be able to do it accurately in your own books? Well, with any luck, you've got squares. And if you have squares, life is awesome because you can literally count squares. That's generally speaking how I do it. But I don't have squares at this moment in time. And so if I join those together, then if I'm really, really lucky, I have a perfect copy of my original shape, but now just reflected in that line. So there is my image, and I'm going to write image in it. Always helps to tell somebody. There are other ways of doing it. You might be asked to shade it. But either way, what I now notice is that I have my object, which is this thing here, and I have my image. Not particularly challenging, no? All right, so now we're going to look at the idea of what if I'm going to reflect in the y-axis. Now again, there's 4 ways we can do this. We normally do it horizontally, which is the x-axis. If I go back to my scales, go back to my axes, I notice that the y-axis is the vertical one. And the way I remember that is y to the sky. I know, weird, huh? But when I'm reflecting in the y-axis, it means that my mirror line is effectively a vertical line. So there's my dotted line. I need a shape. So let's draw something like, let's do something a little bit more funky. And there we go. We've got like an L shape. I'm going to label my corners or my vertices to make sure that when I reflect it, my teacher or my examiner knows where they all are. And all I need to do now is look for distances between each point and that dotted line. So let's start with D. D has a distance there. So I'm going to replicate, and there is my D dashed. E is here in this corner. How far away is it? Well, about the same as D. So there is E dashed. Now, life would be so much easier if I had a ruler, because I could actually measure these things with a ruler. But I'm just going to have to do it at this moment in time with just my eye. Now, because I'm doing this on a stylus or a computer and using electricity to draw, which still freaks me out, then you're just going to have to cope with my approximation. But all I'm doing is, roughly speaking, drawing my points. I'm going to move my F over a little bit. Or my F dashed. So what would this be? This would be A dashed and B dashed and C dashed. And lo and behold, having drawn my corners or my points, I'm now going to join them together to create what I hope will be my image. And while again that doesn't look exact, if you did it on square paper it would be perfect. Just going to shade it in, so that I know that it is my image. I'm also going to write image beside it, and I'm going to write my original, or absolutely let's call it my object. And once again, in an exam, I would be very, very happy with that. Now, people tend to get a bit confused with the next two types, and that's reflecting in the line with what we call y equals x. Going back to my axes, if I draw a quick set of axes, here is my y value, here is my x value. There are special lines on Cartesian planes, on these axes, and one of those ones is where we draw, goodness gracious me, I don't know what's going wrong with my screen today, my apologies, when we draw a diagonal line. So that one there, hopefully I've got this the right way around on my camera, is the line y equals x. And so that's what I'm going to draw here now. I'm going to draw a dotted line that is diagonal. Let's rub this out to give me some space so I know what's going on, but at least you've got that learning if you need to. Right, let's draw some sort of a shape. Let's draw a, I don't know, triangle that looks like that, all right? Slightly off of the mirror line. We're going to label it A, B, and C, and there is my object. We're very happy with that. Thank you very much. What do I do? Well, it doesn't matter whether the line's vertical or horizontal or a slant like that way or a slant that way. It's just about counting the shortest distance or measuring the shortest distance to the line. Now, in this situation, you're not going to measure that vertical distance. I know we did that before. You're measuring the shortest distance to the line, which happens to be at right angles to the line. So that is my shortest distance. Here is my point C dashed. This here is the shortest distance to the line, so I'm now going to do B dashed. And this here is the shortest distance to the line, which gives me A dashed. And again, I know I'm drawing triangles, but for brevity of this lesson, so we don't go here forever, there is the worst diagram I have ever drawn in my entire life. Let's try that again. And let's make that A dashed. Going to shade it in so that I know this is my image. And lo and behold, I have now reflected in the line y equals x. And the last one is the line y equals minus x. And the line y equals minus x basically just does that way. Line y equals x is that way. The minus just does it so that it's actually this way. And once again, I can draw my shape. Let's do a rectangle. Or a square. No, square's a bad shape to choose because reflecting isn't necessarily useful. Oh, I'm stuck with shapes. What can I choose? Let's do that shape there. There you go. Something slightly different. Again, label the vertices as A, B, C, D, and E. And what am I looking to do? Again, just count distances, count squares, use your ruler or measure or whatever you need to do. So there is point A there, equidistant the other side, A, label it A dashed. There is B, equidistant the other side, B dashed. I'm just going to work around C. C is about here, I think, so that's C dashed. D is going to be about here, so there's D dashed. E is going to be sort of here. So let's write that inside as E dashed. And lo and behold, there, there, there. Ooh, I think D is actually a bit further away. So let's do D dash there, E, and there. And again, I know this is challenging because I'm using sort of a stylus and bits and pieces. But again, you can do this with your squares and just count squares. But once again, let's just shade this in. This one here is my image. And this one here is my object. And really, there's nothing more to this than, as I say here, it's just about counting squares and measuring distances. Use your ruler, okay? If I had squares, and this is a really, really quick example with really bad squares. If I now draw my mirror line in a different color, and I have a triangle here, and I know this is going to be hard for you to see because of my red lines, but I now know that this is 1 unit across. So I'm going to draw a dot there. I know that that bottom point is 1 unit away, but this 1 square distance here. And I know this point here is 2 squares away from my line. So there we go. So again, just by counting squares, it's so easy to do this stuff. Now, one of the tricks that tends to throw people is what happens if a mirror line goes through the shape? And you're going to say, what do you mean by that? Well, let's look at this example here. Here is my triangle. And I'm going to draw my mirror line as a dotted line like that. And you're going to go, it doesn't matter. Changing my pen color so I can do this. I'm going to label these points A, B, and C. Now, all you need to do is measure the distance from the dotted line. It doesn't matter which side the dotted line is. Measure the distance and copy it to the other side of the line. So here is my point C, and I'm now going to end up with my point C dashed on that side of the line. That doesn't look absolutely right at all, so I'm just going to move my tablet around. So there is C dashed. Where is my point A? A is on that side of the line, so I'm now going to move it to here. So there is A dashed, and B is going to be, roughly speaking, here. So B dashed. And when I join this together, what do I get? Honestly, I am appalled with how that looks. But the general idea is there. You could draw this much, much, much better. I think my B is way too far out. I reckon if I'd actually put my B dash there, it would look closer to what it should be. But hopefully you're getting the general idea. One day I'm going to do a lesson using GeoGebra, which is a fabulous software tool to show how all of this works. Now, what about if we've been given a shape and we're told to add the mirror line? So let's try and, I don't know, again. Now, again, this seems fairly obvious in terms of the actual shape. But what I'm going to say is this is my object and this is my image. So here is my image and here is my object. And this is A, B, C, and D. And this is now going to be A dashed, B dashed, C dashed, D dash. Now I want to draw my mirror line on. How do I do that? Well, the great thing is all I need to do is find pairs of points and draw a cross or a dot halfway between them. So if we look at B and B, I'm going to do a dot halfway between them. If I look at C and C dashed, there is a dot halfway between them. If I do A and A dashed, there is a dot halfway between them. And we know that because mirror lines, what's on one side is equally far away from the mirror line as the other side, I can now draw my dotted line. And again, I know that was a trivially stupid example, but I don't see how anything is more difficult than that. Finally, for this particular section, and because I'm mapping against the Cambridge Essentials textbooks, it seems weird to now talk about lines of symmetry, but it's in the exercise. So what is a line of symmetry? Well, I think I know someone who can explain this to us. Over to you. Well, a line of symmetry is really easy. Imagine taking a shape and cutting it in half so that when you fold it over, both sides fit perfectly beside each other. Well, that's pretty much it. I mean, there's nothing more to it. Right, so imagine cutting a shape in half and making sure they fit side by side. If they don't fit, it ain't a line of symmetry. All right, see you soon. Well, there you go. And now you have it. There's a line of symmetry. So how do we do this? Well, here is a rectangle. How many lines of symmetry does that have? Well, how many times can I cut it in half and have the top half and the bottom half, or the right half or the left half, look exactly the same? Well, I'm just going to do that now. So there is one dotted line and there is another dotted line, and lo and behold, that's actually it. So in this situation, that shape there has two lines of symmetry. What about this shape here? Now here is a bit of a trick for you, because at this moment in time you don't know what that triangle actually is. If it's an isosceles triangle, okay, that's good. If it's an equilateral, then there's a different one. If there is a scalene triangle, there's a different one again. If it's a right angle triangle, it's a different one again. So what I'm going to assume now is I'm going to draw two lines just there and there, which tells me it's an isosceles triangle. As a result, that means I can cut this smack bang down the middle, and there is only one line of symmetry. What about a square? Oh, if you love the square. How am I going to show squares? I'm going to draw those two little marks there to say that it's a square. How many times can you cut this shape in half such that if you folded it over on each other, it would match exactly with no sticking out? Well, obviously the first one is there. This is an obvious one horizontally, but as it turns out, because it's a square, I can actually cut these there and there as well. And so this would have four lines of symmetry. The last one, which is a bit of a trick, is the circle. How many lines of symmetry does that have? As it turns out, you can draw lines of symmetry on this shape forever and ever and ever, depending on how far or small you want to make the divisions. Now, lots of people say 360 because we think there's 360 degrees in a triangle, in a circle, but it isn't. Actually, it is infinity and beyond. All right, so lines of symmetry, not particularly challenging, so long as you just try and say to yourself, where can I cut this such that if I folded it over, it would look the same on one side as the other. Now, obviously, with a rectangle, be very, very careful. Lots of people think that when you have a rectangle, you can cut that in half and it will map over. My advice to you is grab a piece of A4 paper, which is obviously a rectangle, in fact, any piece of paper that's not square, and fold it down that middle line. And I can promise you, it does not look the same. All right, ladies and gentlemen, there we go. Today's lesson on mirror lines and reflections. We're about to start a 45-second Twitter recap. What did we work on today? We've looked at reflections and we've looked at what it is we were trying to learn. I gave you a practical task and I said, look in a mirror. And I said, what do you see? And if you see someone behind you, then run. It's a cheesy horror movie. We moved on and I had my little Cuthbert the crab talk about the lingo before talking about how we can draw mirror lines in 4 different ways. That way, that way, that way, that way. It looks like I'm dancing. We did 1, 2, 3, 4 examples, and we decided really this was about counting squares or counting the distances. We looked at what happened when a mirror line goes through shapes and how to add mirror lines halfway between before recapping lines of symmetry, which seemed an odd place to put it. But you know what? That was a good lesson. And breathe. Wow, there you go. Ladies and gentlemen, thank you very much for watching. If you have made it all the way to the end, again, if you think of a name for the crab, leave it below. If you'd like to like the video, like the video. If you would do me this honor and haven't already done so, send out a message on Facebook, send out a message to your friends on Instagram, on Snapchat, on Twitter, or wherever it is, and let them know this channel is here and they could possibly watch it to help. Otherwise, there is a subscribe button. Go on, subscribe, please. Stop making me beg. It's weird. Otherwise, there is a video for you over there to watch. Thank you again. This is the MaffsGuru. Out.